All right, next example that we have here, we are to find the maximum of the function f, defined here, on the interval -1 to 2. So, very similar to the previous example. We'll first begin by finding critical points. So find the critical points, which we do by first taking the derivative. And this is, let's see here, this would be -2/3 x minus 1. We'll subtract 1 to have 2/3 minus 3/3 is -1/3 times the derivative of the inside, which is 1. I will take the opportunity here to rewrite this slightly. Put a 2 in the numerator, 3, and this is x minus 1 to the positive 1/3. Negative exponents are great for taking derivatives, but they're not always the best for doing algebraic manipulations when you're trying to solve things. Sometimes it is nicer to think of it in the denominator. So that's our first derivative. So now what we want to do is we want to see where this first derivative, if anywhere, doesn't exist. Notice here that our first derivative is not a polynomial. We've got a fractional exponent, so it's not a polynomial, and also it's in the denominator. So it's definitely not a polynomial. In fact, because this term is in the denominator, when x is equal to 1, we get division by 0. So I'll say here that f prime does not exist at x equals 1. And now we have to make sure that this x equals 1 is in the domain not only of our function. So look up here at our original function. Are we able to plug in x equals 1 here? Is that a problem? No, it's not a problem at all. That's fine. We're allowed to raise 0 to the 2/3 power. That's just 0. So f of 1 is just 1 minus 0, which is 1. So that's perfectly fine here. But also, is this x equals 1 in the domain that we're given? We're only supposed to consider x values between -1 and 2. Well, x equals 1 definitely lives here, so we have found one critical point so far. So moving on, we want to check to see where f prime of x equals 0. But whenever you have a fraction set equal to 0, the only way a fraction is equal to 0 is if the numerator is able to be 0. So the numerator here is 2. Well, 2, there's no x here, right? If this were 2x, then when x equals 0, the numerator would be 0. But there's nothing we can plug in for x that would change this 2 into a 0. It's just 2. So I'm going to go ahead and say that f prime of x never equals 0, since 2 does not equal 0 ever. So there's only one critical point that we found, and it was where the first derivative does not exist. So the only critical point is x equals 1. So now that we've done that, step 2 is to compare values. So we want to plug in the endpoints of f, so f of -1 and f of 2, as well as f at our critical point. So we already said that f of 1 is equal to 1, so we'll just write that down. F of -1 is 1 minus the cube root of 4. And f of 2 is 0. So clearly, this right here is going to be the minimum. And this right here is going to be the maximum.